Section 7.2, homework problems. Okay, a normal distribution has a mean of 15 and a standard deviation of 4. Find and interpret a z-score of x equals 11. Okay, so z is going to be equal to x minus mu divided by sigma. So x is 11 minus mu is 15 divided by sigma, which is 4. So this is going to be minus 4 over 4, which is a minus 1. So this means that a value of 11 is 1 standard deviation below the mean. So it's 1 standard deviation below the mean. So pretty much you have your standard normal curve. The mean is in the middle with a z-score of 0, minus 1, minus 2. So we're right here, 1 standard deviation below the mean. Okay, the next one. A normal population has a mean of 20, standard deviation of 4. What proportion of the population is less than 18? Okay, this is a less than problem, so whatever number I look up in the chart will be my answer. So I have the formula again. Z is x minus mu over sigma. So it's going to be 18 minus 20 divided by 4. So this comes out to a negative 2 divided by 4, which is a negative 0.50. So I'm going to look this up in A2. So I go to my tables and I want to look up a negative 0.52. So let's see. Let me erase all this. Okay, so I'm looking up a negative 0.50. Negative 0.5 is right here, and the 0 line is right here. So the number that I want is right here. That's my answer. Next problem, part B. What's the probability that a randomly chosen value will be greater than 25? All right, so now this is greater than 25. So when I look up the number, I have to subtract from 1. And how do I know that? Because that's on my shortcuts right here. When it's greater than, I look it up and I subtract it from 1. So the formula, z, x minus mu divided by sigma. So let's see, x is 25, the mean was 20, divided by 4. So this is going to be 5 over 4, which is 1.25. So I'm going to go look that up in the chart, 1.25. So 1.25 1.2, and the 5 is here. So the number I want is 0.8944. So 0.8944. So since this is greater than, I subtract it from 1 and I get 0.1056. So that's the probability that a randomly chosen value will be greater than 25. Baby weights. According to a recent National Health Statistics report, the weight of a male baby less than 2 months old in the United States is normally distributed with a mean of 11.5 and standard deviation 2.7. What proportion are going to weigh more than 13? So more than, I got to just subtract it from 1. So first I calculate z, x minus mu over sigma. So it's going to be 13 minus 11.5 divided by 2.7. So that's 1.5 divided by 2.7, which comes out to 0.555. Since I'm looking this up at, this is my Z number, I need to round that to 2 places. So I'm going to look up 0.56 on the table. So I'm looking up 0.56. There's 0.5 and 6 is here. So it's 0.7123. So that comes out to 0.7123. Since this is more than, I have to do 1 minus 0.7123. So the probability is 0.2877. B, less than 15 pounds. So again, the same formula, x minus mu over sigma. So it's going to be 15 minus 11.5 divided by 2.7. So it's going to be 3.5 divided by 2.7, which is 1.29, and again 6. So I need to round this. So I'm going to look up 1.30. It's important that you're rounding these the right way before you look them up. So I got to look up 1.30. So 1.30. So that's going to be right here 0.9032. So 0.9032, since this was a less than, the less than is the answer, so my answer is 0.9032. All right, part C. Part C is an in-between, so I have to do both of these and then subtract them. So again, as a review of my shortcuts, the in-between is right here. It's an in-between, so I calculate them, look them up, and subtract. So let's give that a try. So first it's 10. So formula is x minus mu over sigma. So it's going to be 10 minus 11.5 divided by 2.7. So that's a minus 1.5 divided by 2.7, which is a minus 0.56. I'm just going to look that up right now. So a minus 0.56. So I have to get to the negative side of the chart. Negative 0.56. It's right here. 0.2877. So it's going to be 0.2877. That's one number. Now I do the next number, which is a 14. Right here, 14. So 14 minus 11.5 divided by 2.7. So that comes out to 2.5 divided by 2.7, which is 0.925. So I need to look up 0.93. Go to my tables and look up 0.93. It's on the positive side. So 0.93 is 0.9, there's my 3, so it's 0.8238. So this is 0.8238. So this is an in-between, so my answer is going to be 0.8238 minus 0.2877, and the total answer is 0.1115. Is it unusual for a baby to weigh more than 17 pounds? So first of all, this is a more than problem. So I use the exact same formula. C is equal to x minus mu over sigma. So it's going to be 17 minus 11.5 divided by 2.7. So this is going to be 5.5 divided by 2.7. which is 2.037, and I have to round that to a 4, so 2.04. This is what I look up. 2.04 in the table. So 2.04, 2.0, and the 4 is right here. So that is 0.9793. 0.9793. Since it says way more than, I have to subtract it from 1. So 1 minus 0.9793 is going to be 0.0207. And the conclusion is if 0.0207 is greater than the 0.05, not unusual. But it's less than. So yes, it's unusual. So this is a yes. So you compare your answer with 0.05. If it's less than the 0.05, it's a exam grades. Let's see, we have a mean of 75, standard deviation of 8. What proportion of scores were above 90? So same formula, x minus mu over sigma. So above 90, so I'm going to do 90 minus 75 divided by 8. So 90 minus 75 is 15 divided by 8. That's 1.875. And this is going to round up to 1.88. That's what I have to look up. So I'm looking up 1.88 in the table. 1.8 and 8. So it's 0.9699. So 0.9699. And the answer is above. So above is greater. So it's 1 minus 0.9699. So my answer is 0.0301. B. What proportion of scores were below? All right, so this is below is less than. So whenever I look up, that's my answer. So 65 minus 75 divided by 8. So I get a minus 10, watch your negative sign, divided by 8, or a minus 1.25. That's what I'm looking up, a minus 1.25. So I'm on the negative side of the chart. Minus 1.25 is here. And the answer is 0.1056. So it's 0.1056. And since this is a less than, that's my answer. The next one is a between. So again, I calculate them, look them up, and subtract. So it's going to be 70 minus 75 divided by 8. So I get minus 5 over 8, which is a minus 0.625 or negative 0.63. So when I look up a negative 0.63, negative 0.63 is here. So it's 2643. So this is 0.2643. Then I do the next calculation, 80. So I do 80 minus 75 divided by 8. That's a positive 5/8, so a positive 0.63. So I look up a positive 0.63. Positive 0.63. So it's 0.7357. Since this is an in-between, I subtract, so 7357 minus 0.2643, and my answer is 0.4714. So the probability that a randomly chosen grade is going to be between those is 0.4714. Percentiles. Okay, percentiles are done slightly different. We still have the mean here of 80.4, standard deviation of 9.8, but this is the one where we're using the other formula. So we're actually going to calculate x. So we rewrite the formula that we just used, so it's solve for x, and we have to calculate z. So for the 40th percentile, when you're looking at percentiles, you convert them to decimal, so 40 divided by 100, so it's 0.4000. This is what I want to look up in the middle. So this is the backwards one. So I go to my table and I want to find 0.4000 in the middle. So 0.40, looks like it's right here. So it's either 0.4013 or 0.3974. 0.4013 is closer, it's only 13 away. This is 26 away. So now I stretch that out and see what it corresponds to. So it's a minus 0.2, and then I go up here, 5, minus 0.25. So that's what Z is. So Z is a minus 0.25. So now I plug that in. So the mean was 80.4 minus 0.25, or plus a negative, times 9.8. So I do minus 0.25 times 9.8 is going to be a negative 2.45. So I do 80.4 minus 2.45. That gives me a x equal to 77.95. That's my x. B, 66 percentile, so I do 66 over 100, which is 0.6600. I want to look that up in the chart, in the table. So I'm looking at 0.6600, so it's going to be on this side. 0.6600. Looks like it's right here. This is 9 away, this is 28 away, so this one's closer. Right here. So that corresponds to 0.41 for my Z. So Z is a 0.41 on that. So I'll put in the formula, x is equal to 80.4 plus 0.41 times sigma. So 0.41 times 9.8 is 4.018. Add 80.4 to that. And I get x equal to 84.418. All right, part C. Find the first quartile of the blood pressures. First quartile is 25%, so it's 25 over 100. So I'm looking up 0.2500 on the chart. So 2500 is on this section. So 2500. Right here. So 2514, that's 14 away. 2483. That's 17 away, so I'm going to take the 0.2514, and that corresponds to negative 0.67. So negative 0.67. So x is going to be 80.4 plus a negative 0.67 times 9.8. Negative 0.67 times 9.8 is a negative 6.566. And then I want to subtract that from 80.4. And my answer comes out to 73.83. 3, 4. And of course you have to round. This one's at least 2 decimal places, so this is fine.